Let's write an example for hello world. We will use both the methodologies to create a thread. Let's say we have two threads. One thread displays hello, another thread displays world. So since there are two different messages that each thread has to display, but the functionality is same, just to display some message, okay, we'll have the same functionality being executed by two threads, but the message that it displays would be different. So we'll have class thread test, which will have public static void main of string array. Here we'll create new disp thread object. Now what is this disp thread? We have a class disp thread. Let's follow the steps that we wrote. We are going to look at the first method, extending by the thread class. First method says extend a class from the thread class. So we have a class which extends from thread. The next step says override the run method. So public void run. In this run method, all we want to do is display hello, whatever the message, right? Now where is the message coming from? Now remember, both the threads are going to execute the same run method. So if you want to have two different messages, we need to pass the message to disp thread somehow, and that is through a constructor. Let's say hello will be displayed by disp thread 1. And similarly, we will create another disp thread object, dt2 is equal to new disp thread which takes world, which means to say that I need to have a constructor here which takes a string message which I need to display here. But how do I access this local parameter out here in this method? Declare a variable here in the class to which you equate the local variable value and access the message in the run method. Let's say we put it into a for loop, for int I is some value as long as int I is 0, I less than some value, I plus plus. In this you write the SOP to display the message. So once you have overridden the run method, we said create an instance of the class. So we created two instances of that class. Thereby we got two thread objects because the class extends from the thread. An object of that class is nothing but a thread object. Next, call start on the thread. So dt1.start and dt2.start. Which ends up executing the run method out there. Now let's see how the execution happens. When I say Java thread test, a main thread or the system thread executes the main function, and the system thread creates an instance of this particular class When it does so, it executes the constructor, comes back here, again creates the next instance to execute the constructor and comes back here. Till now we still have a single thread, that's a system thread. Now we call dt1.start. The start gets called within the main thread, which creates a separate path of execution for dt1. So in that separate path of execution, the run method is called for dt1. Then dt2.start is called. So again inside the main thread, this is start is getting executed. The start again creates another path of execution within which the run method for dt2 is getting executed. And when the main thread, the next thing the main thread does is, it's done. That's the end of the main thread. Main thread has exited. But that does not mean my program execution is done, because now I have two user threads running still, the child threads. The child threads go into their loop to execute the loop to display the message n number of times. Once they are done, the entire program comes out of execution. This is how threading works. Now let's take a look at the second methodology. The second methodology says, take a class, implement it with the runnable interface, implement the run method, create the instance of the class. When you create the instance of a class, what type of an object do you get? You get a runnable object. You don't have a thread object. You need to create a thread object. So create the thread object. Thread T1 is equal to new thread of, pass the runnable object to it, dt1 and dt2, two different runnable objects, because we want to have two different messages for each of the threads. Call the start on the thread. This is the second methodology to execute the same program. Now what is the difference between implementing runnable and extending from the thread class? The difference is, if you wanted to extend from the thread class, it's possible only if you are not extending from any other class, because it's a single multi-level inheritance in Java. Whereas implementing an interface can be done on any class easily. Another important point is that if you extend from the thread class, the entire functionality of the thread is inherited into your class, and you can override the functionality of any of those methods of the thread to give your own definition. And you are loading the entire content into your class, the entire characteristics into your class, which becomes heavy. That's the difference. Rather than creating an instance, you are simply extending by the thread class, you are inheriting all the contents just to override the run method. That's the difference between implementing runnable versus extending the thread class. That's why implementing a runnable interface is a preferred methodology.